So in this video, we're going to close off the chapter 2, and the final topic is further sequences and series. So this is basically some additional types of questions that you may see, and yeah, so we are going to solve these questions. All right, question 1 is you're given the first term and the second term, and you need to find the sum of the first 8 terms. So if the sequence is arithmetic, you are given the first term is 16, and the second term, which is a plus d, right? The second term is going to be a plus d if it's arithmetic. That is 24. So you know that a is 16, so 16 plus d is 24, and therefore d is just 8. All right, so now you need to find the sum of the first 8 terms. So sum of 8 terms is just n divided by 2, 2a plus n minus 1 d, right? And then you just substitute. N is equal to 8. 8 divided by 2, that gives me 4. 2 times a is 16. 2 times 16 is 32, plus 7 times 8, that is 56. D is 8, and then 8 minus 1 is 7. So 7 times 8 is 56. And when you substitute everything in and you solve, you get 32 plus 56 times 4, that is 352. So you just want to sub into this formula. N is equal to 8, which you get from here, which is the number of terms. And a is the first term, and d is the common difference. All right, and part B, the series is geometric. So a is 16, r is 24. So 16 times r is equal to 24. R is equal to 24 by 16, and that is 3 by 2. And now if you want the sum of 8 terms, that is r to the power n minus 1 divided by r minus 1. So that is 16 times 3 by 2, that is also 1.5. So 1.5 to the power 8 minus 1 divided by 1.5 minus 1 is just 0.5. And when you use your calculator to evaluate this, you get 788.125. So all right, we're done with question 1. Question 2. The first term of a progression is 20 and the second term is 16. So first term is 20 and t2 is equal to 16. So it says given that the sequence is geometric, that means AR is equal to 16, right? Or 20 times R is equal to 16. So R is going to be 4 over 5, right? 16 by 20 is the same as 4 over 5. That is 0.8. And it says find the sum to infinity. So sum to infinity is just a divided by 1 minus r. These are formulas that we have looked at over and over again. So your first term is 20 divided by 1 minus 4 over 5. And that just gives you 100 if you simplify. And it says, given that the progression is arithmetic, find the number of terms in the progression if the sum of all the terms is negative 160. So now we are given that it's an arithmetic progression. So the second term would be a plus d. A plus d is given to be 16, and a is 20 plus d is 16, so d is negative 4. And we know that the sum of n terms, we don't know how many terms, but the sum of them is negative 160. So now let's just write the formula. N divided by 2, 2a plus n minus 1d, this sum is negative 160. So if I multiply by 2 on both sides, I can cancel out the 2 in the denominator. So n, and I know 2 times a is 20, so 2 times a is 40, plus n minus 1, and I know the common difference is 4. That is negative 320. And n, if I simplify whatever I have inside the bracket, I get 40 minus 4n plus 4. So that is 44 minus 4n equal to negative 320. And I can actually divide by 4 on both sides. And if I divide by 4, I get n times 11 minus n, I'm dividing by 4 on both sides, is equal to negative 80. And it follows that 11n minus n squared is negative 80. So if I take everything to the other side, I get n squared minus 11n minus 80 is equal to 0. And now let's try to factorize this. Because n has to be a whole number, right? It has to be a natural number. It has to be a counting number. So now, when we try to factorize this, I believe we get, so we need two numbers that multiply to give us 80. So that's 8 and 10. 8 10s are 80, but they don't add up to negative 11. So let's think about it. Or we can just use the quadratic formula. I think that would be easier. So n would be minus b, which is minus of minus 11, plus or minus the square root of 11 squared, 121, minus 4 times 1 times negative 80. So that is going to be plus 320 all over 2. 2 times a is just 2 in this case. So this is in the hopes that you have been taught to use the quadratic formula, and you should have in grade 10. So this square root evaluates to 21 divided by 2. So we don't want a negative n, so we're just going to add. So I believe this gives us 32 divided by 2, and your answer is just going to be 16. So n has to be equal to 16. All right. So we are done with question 2. Question 3. The first, second, and third term of a geometric progression. So let's say we have a geometric progression and we have t1, t2, t3. And let's just say we start from a, and t2 has to be ar, and t3 has to be ar squared. Are the first, fourth, and 10th terms respectively of an arithmetic progression. So this is the first term in an AP. This is AR is the fourth term, and AR squared is the 10th term of an arithmetic progression. Given that the first term in each progression is 12, so the A is just 12, so we have 12R and 12R squared. And in the arithmetic progression, our first term is going to be 12 as well. And R is not equal to 1. Find the value of R and the sixth term. All right. So how would we represent the fourth term? Well, that would be A plus n minus 1. So 4 minus 1 is 3D. And that is equal to 12R. And similarly, how would we represent the 10th term in the arithmetic sequence? That would be A plus 9D. And that is equal to 12R squared. All right. Now I know the value of A. That is just 12. So 12 plus 3D is equal to 12R. And 12 plus 9D is equal to 12R squared. So now, if I compare, right? So if I say, hey, 12 plus 9D squared is equal to 12R, and 12 plus 3D is equal to, 9D, no squared, is equal to 12R squared, and 12 plus 3D is just 12R. So if I subtract both sides, I get 12 minus 12, that collapses to 0. 9D minus 3D, that is 6D, is equal to 12R squared minus 12R. And if I divide by 6 on both sides, I should get D is equal to 2R squared minus 2R. And if I can factor out the 2R, R minus 1, that has to be equal to D. So I just factored out 2R. And I have been given that R is not equal to 1. Given R does not equal to 1. Alright, so now let's think of how we can use this information. So we know the value of the common difference in terms of R, and we know the correspondence. And so now I can substitute this value of D here to find R. So let's pick the simplest equation, which I believe that would be the one. So 12 plus 3, 2R times R minus 1 is equal to 12R. And let's just solve this. So 12 plus 3 2s are 6R times R minus 1 is equal to 12R. So 12 plus 6R squared minus 6R is equal to 12R. And if I divide by 6 on both sides, I get 2 plus R squared minus R is equal to 2R. And now, if I bring everything to one side, I get r squared minus 3r plus 2 is equal to 0. And I can solve this quadratic equation. That would be just, if I factor out stuff, I get minus 2 minus 1, right? So r is just 2. Because we already know r does not equal to 1. So this is not possible. You use this to get r equal to 2. And again, you can try factoring out on your own. I know I did it a bit quickly, but yeah, the value of r is just 2. And find the sixth term of each progression. Well, T6, if the series is geometric, then T6 is just ar to the power 6 minus 1. That is 5. So that is 12 times 2 to the power 5. 12 times 32. And 12 times 32 is 384. And if the common difference, so let me use this value of r here. So d is just 4 times 1 is 4. All right, so T6 is equal to a plus 5d is equal to 12 plus 5 4s are 20. So I substitute d here, and that is 32. So 384, and if it's arithmetic, then it's 32. The sixth term of the arithmetic sequence is 32, and the sixth term of the geometric sequence is 384. All right, so we're done with question 3. Moving on to question 4. So geometric progression has 8 terms. The first term is 256, and the common ratio is half. So we have a geometric progression, and the first term, let's say, is a, which is 256, and r is equal to half, and n is equal to 8. We have 8 terms. And we have an arithmetic progression. So this is for GP. We have for an arithmetic progression, let's just call it n dash is equal to 51, and d is equal to half. And it says the sum of all the terms in the geometric progression is equal to sum of all the terms in the arithmetic progression. So let's use this line of information. Sum of all the terms in the geometric progression is equal to sum of all the terms in the arithmetic progression. So sum of 8 terms in the geometric progression, what's the formula? Well, it's a, 256, times r to the power n minus 1 divided by r minus 1. So that is just negative 0.5. And if you simplify this further, you can actually solve this question, right? You can find the sum of 8 terms, basically. 256, 0.5 to the power 8 minus 1 divided by negative 0.5. And this is 510. And now we add up all our terms in the arithmetic progression. That would be 51 divided by 2, n by 2, 2a, we don't know what a is for the arithmetic progression, plus n minus 1. 51 minus 1 is 50, and we know the common difference is half. So 50 times half is just 25. And that is equal to 510. They are equal. The sums are equal. Now we can solve this equation. If I divide by 51 on both sides, I get 10 on my right-hand side. And I can multiply by 2 so that the 2's cancel out. So I know that 2a dash plus 25 is equal to 20. So 2a is equal to negative 5. 20, if I'm subtracting 25 on both sides. So a dash is equal to negative 5 over 2. And that is negative 2.5. So that is the first term of the arithmetic progression. And it says find the last term. So last term is just the 51st term, right? Because we have 51. So that is just a plus n minus 51 minus 1 is 50d. And a is negative 2.5 plus d is half as well. So 50 times half is 25. And that, I believe, gives me 22.5. So that is my answer for question 4. Moving on. Question 5. The first, second, and third terms of a geometric progression. So it's a very similar question. So we have a geometric progression, GP. So we have A, AR, and AR squared. So that's my first, second, and third terms. So in an AP, they are the first, sixth, and ninth terms. So sixth and ninth terms of an AP. Given that the first term in each progression is 100, so A is 100, so this is 100R, and this is 100r squared. And the first term in an AP is also 100. And the common ratio is of the geometric progression is r, where r not equal to 1. So we are asked, it's a very similar type of question. So it says find the value of r. All right. So the sixth term of an arithmetic progression, that would be a plus 5d, right? 6 minus 1d. So a is 100. And that is 100r. And from this equation, I know the ninth term is just a, 100, plus 8d. And that is equal to 100r squared. All right. So now we can do the same trick. We put the equations together and we subtract. So 100 minus 100, that is 0. 8d minus 5d is 3d. And we have 100r squared minus 100r. So 3d, I know, is equal to, or d is equal to, if I factor out 100 and I divide by 3, right? So I factor out 100 and I divide by 3, r squared minus r. All right, and I can substitute this back here. So I know that 100 plus 500 by 3. So I just substitute d. R squared minus r is equal to 100r. All right. So now let me simplify this equation. I multiply by 3 on both sides. I get 300 plus 500. R squared minus r is equal to 300r. 300 plus 500 r squared minus 500r is equal to 300r. And let me divide by 100, right? So I get I get 3 plus 5r squared minus 5r is equal to 3r. And now 5r squared, if I convert this into a quadratic equation, I get minus 8r plus 3 is equal to 0. So let's solve for r. R is equal to minus of minus 8, 8, plus or minus square root of 16, minus... So it looks like we made a mistake. So it seems that we have made a mistake somewhere. So let me just check where we made a mistake. Multiply by 3 equal to 300r divided by 3. So 5r squared minus r plus 3 is 0. B squared minus 8 squared is 64. Minus 4 times 5 is 20, minus 3 is 60. Over 2 times 5, that is 10. So 8 plus or minus, that is square root of 4, is just 2 divided by 10. And therefore, it is given r does not equal to 1. So 8 plus 2 is 10 by 10 is 1. So we have to take 6 by 10, or 0.6. So you just get both answers and you reject the case where r is equal to 1. So r is equal to 0.6. It says find the fifth term of each progression. So let's just find d first. So d is just 100 divided by 3. 0.6 squared, that is 0.36 minus 0.6. And if you put this in your calculator, you get d is equal to negative 8. So now we have to find the fifth term. So if it's a geometric progression, the fifth term is ar to the power 4. So our starting term is 100 times 0.6 to the power 4. And that gives us 12.96. And this is considering a geometric progression. And if it's the arithmetic progression, the fifth term is a plus 4d. And that is 100 plus 4 times negative 8. So that is 100 minus 32, 68. So 12.96 and 68. That is the answer. All right, we are done with question 5. So 0.6, 6 by 10 is also 3 by 5. All right, question 6. First term of an arithmetic progression, that is t1, is equal to 16. And the sum of the first 20 terms is equal to 1080. So t1 is just a. And sum of 20 terms is, so sum of 20, so n is 20. Let's remember. So find the common difference of this progression. So we will use the sum of 20 terms. And that is just 20 divided by 2, right? N divided by 2. 2 times a, 2 times 16 is 32, plus 20 minus 1 is 19d. And we know this is equal to 1080. So 20 divided by 2 is 10, and if I divide by 10 on both sides, I get 108 on my right-hand side. So 19d is equal to 108 minus 32. And when you solve for d, 108 minus 32 divided by 19, you get d is equal to 4. So your common difference is just 4. And then it says the first, third, and nth term. Alright, so our first term is 16. Our third term is a plus 2d. So 16 plus 2d. 16 plus 2d is 24. Our third term is 24. And nth term. So the nth term is just 16 plus n minus 1d. Our first, second, and third terms of a geometric progression. So 24, we know, is equal to AR. And they have the same first term. So A is still 16. So R is just 24 by 16. So the common ratio is just 3 by 2, is 1.5. So that is the common ratio. And the value of n. So nth term is equal to the third term of the geometric progression, right? So what is the third term? That would be AR squared. So 16 plus, and we know d. d is just 4, I believe. So we can substitute. When we evaluate the left-hand side, we get 4n plus 12. I believe, yes. And then AR squared. So that would be just 16 times 1.5 squared. And we are just asked to solve for n. So 4n is equal to 16 times 1.5. 16 times 1.5 squared gives me 36. 36 minus 12, right? I have to subtract 12 from both sides as well. So that is 24, and therefore n is equal to 6. And that is my R value. So we are done with question 6.